And I'm going to talk through here, sorry if I'll draw these on the board. Intersection of three planes. I am a teacher, and I apologize for this, Matt. I apologize before we begin here. I am a teacher who is unfortunately pressed for time this semester. So what we're going to do for this, we're just going to deal with the algebra. This is my demonstration of three planes look like. The way three planes can intersect is this, which is option number one. How many times does this plane intersect? Zero. There will be no intersections of all three planes. Okay. Here is option number two. You don't write these down. These are in your textbook. Okay, I'm not going to quiz you on these. You'll not be asked. How many intersections does this have? All three planes are exact. This is the boring case where they're all the same. Okay. Option number three. Now this is a neat one. This is a letter A. How many intersections are there here? There are actually zero intersections. Okay? These planes do not all three of them do not intersect. You ever see this one? That is a trick question.
Trick.
Number four. This is hard to see. This is a unique case where these all intersect. Where are these going to intersect? What's the solution going to be in this strange case?
That line right down the middle.
This is going to be a line. This is a rare case. Okay, this is where all planes magically go to the same spot, which is miraculous. Case number 5 is what we're going to deal with.
I like that one.
Okay. Now I'm going to get you guys to pass this around quickly, and then I'm going to send it back to the front. So just quickly pass that around and tell me what the solution of those three planes will be. So there's our textbook, Andy, because I'm just going to say refer to a page. Okay, so while I'm doing this, I'm going to everyone just pass around quickly, and you can think in your mind, do not yell it out. Excuse me. What the solution will be for that. I'm going to say refer to diagram. On page 490. Please note I will not be quizzed on that. Okay, I'm not going to say, please replicate this diagram. Okay, I will not say that, but for information for that. Okay, please, so this is a gift. These are gifts from Mr. Custer. Please do not destroy them. Has everyone seen that piece of paper yet? We're moving here slowly. This half the class has seen it. Okay. Okay, what is the solution? A single point. Okay, so what we're going to deal with here is it is possible for all three planes to intersect at a point. Okay, so there will be a unique X, a unique Y, and a unique Z. Okay. As I mentioned for this, I'm interested in the algebra this year for the sake of time. I'm sorry I'm rushing you guys. You can curse me next year at university if they quiz you on the 6 parts of the plane, or the 6 ways that three planes intersect. Okay, I apologize. Okay, but this is what we're going to use for that. All right. So I'll take that, John, if everyone else is done here. But this is sort of tricky. This is tricky, okay? Like you think that is only a point. They intersect. Okay, so how do we do this? To find the solution. Step number 1 will be convert all planes to scalar form. Number 2 will be use manic substitution. That's not the technical term. Why is it manic? Or matrices to solve.
Does manic mean insane?
Yeah. Okay, what this is, you could use technically. Do you remember that question I gave you guys on your first test? No, it was your second test. Actually, the third test. The one where I said f of 1 is equal to 3, f prime of -1 is equal to 2, and f you had an A and a B and a C and an A and a B and a C, and it took you this much to solve. We're going to show you today how to solve it
Are we allowed to write
quickly.
programs for that?
No, you're not. Okay. But we're going to use matrices to solve this. I will also, before we start, and I want to make sure that Austin and Kayla are getting this, they don't hear this clearly. On your test on Tuesday, there will be a 4x4 matrix to be solved. Okay. You cannot do, let me rephrase, you can do that with algebra, but it will literally take you the rest of your life to do, so please don't. No, you are not. Okay. No, you must use one of my calculators on the test. You cannot use your own calculator on the test. Okay, if you have, sorry? Because there are ways to do matrices on your test, and that's not fair. It'll be, I will want to see the mid steps anyway. So.
I just confused you now.
Here we go. So here's what a matrix is. Okay, so what a matrix is something like this.
It's ICES.
Okay, so these are going to be the coefficients of x, y, z. This is going to be the right-hand side of equal. So this would say x plus 2y plus 3z equals 7, 4x plus 5y plus 6z equals 8. That's what that matrix represents. Okay. So what matrices are meant to do is a way to organize, to do substitution in an organized fashion. The problem, if you remember doing substitution like we did before and I did it on the board, is that you have numbers and equations going all over the place and you drop a negative, and that's the issue, right? It's very easy to make a mistake. The theory is with matrices is that when you do them, you're very structured, very organized. There is a formulaic way to do it, okay, so you do not make mistakes. If I was teaching you computer science right now, I would say you can follow the exact formula to do it all the way through. Not that you guys care, but I'll tell you anyway. In my grade 12 programming class, in ISU, I had a former calculus student make me someone that could solve an n by n matrix, that being like 20 by 20 or 50 by 50, you get the program to do it very easily. Okay, so we're going to deal with relatively small ones today. Okay, but you'll see the pattern that we follow. Okay, here are the rules of matrices. I'll get my notes here instead of going up.
There are no rules. Don't talk about it.
Oh, that's Fight Club. Okay, no one's ever seen the movie The Matrix, or else it'd be like random jokes going here.
I just made a reference.
So before I talk about the movie The Matrix, which I'm not going to.
Do we get to watch The Matrix?
No, we do not get to watch The Matrix.
Oh, okay, was that Ronnie who did that exam? Now it's time to enter the matrix?
I'm sure he did, I don't know.
He wore a suit to the exam and I said, now it's time to enter, when he was at the matrix scene part, and then he put his sunglasses on and said, now it's time to enter the matrix. I guess it was really funny.
I don't remember that. It could have happened here, though.
Let's do it.
Okay, so here we go, rule operations. Here we go. Number one. We're going to say any row can be multiplied or divided by a non-zero constant. So the same rules of algebra apply. If I have x plus 2y plus 3z equals 7, I can multiply it by 2 and call that 2x plus 4y plus 6z equals 14. And I can change this the same way, 2, 4, 6, 14. Right? They're the same rules apply. I can multiply or divide. Right? Number 2 says any two rows can be interchanged. What that means is, let's say that Robbie looks at this and he doesn't like it to say 1, 2, 3, 7, 4, 5, 6, 8. He can say an equivalent matrix would be 4, 5, 6, 8 in the top, and 1, 2, 3, 7 in the bottom. That hasn't changed. Right? They're still the same two equations that I've done there. And this is the biggie, is number 3. Okay. I'm going to put in brackets like elimination, and then I'm going to write the definition. But number 3 is like the elimination step. Okay, from grade 10. We're going to say any row can be replaced by the sum or difference of that row and a multiple of another. Now, it sounds complicated when I say it like that, but it's like elimination, right? Remember when we did elimination in grade 10 and yesterday, you multiplied a row by something, we added to the other row, right? That's what we did for elimination, right? So for this case, I could multiply this row by 2 and add it to this and get a new row. So that's what they're saying. Okay? Most people in data management, does that make sense what I said there? Data management? It's basically elimination from grade 10, that's what it is. I'm going to show you the goals and the final step. You want to have a matrix that looks like this. What that is one's along the diagonal. Zeros underneath.
Sadler,
Yes.
is that a 4 by 3?
Yes. Yeah. The final line we wanted to have look to something like this. Okay, can anyone try and translate what that final row, can somebody read out in English what that final row is going to be? Go ahead.
It should be x equals 4,
Yeah.
y equals 5, z equals 6.
Now, if for those people that have not been in data management, this is me trying to simplify things out for you. Okay, so I will go through as many examples as I can say. If I can get through 5 today, I'm going to do 5.
You could write that out, like, it's, in its full sense, it would be x plus 0, y plus 0.
Yes, yes, but we're not going to do this. Is what we're saying for this.
Like,
Yeah.
that's really
Right.
good.
Okay, but this is what we're going for. So on the in-between steps, what you're trying to do is get ones across the diagonal. That's what you're trying to do for an in-between step. Once you've done that step, get zeros underneath, and then make it look like that, and then there's your solution. Anybody say, Mr. Sadler, this looks evil? Okay, it's not. Once you do a few of them, it really speeds things up for you. It makes your life easier. Okay, it really, really does. I know Shannon's not convinced. Shannon's saying, I wish I was... Oh, you're not convinced? Okay, it is. So you should feel bad about leaving now, so you've done that. Okay. What I'm going to do on your test, let's start with an example from the question, then we'll let Shannon go, and then Shannon, I'm going to hit pause, Shannon, and then ask you a question.